Okay, so this is going to be problem number 20 on the 2022 AMC 10B. One of my viewers requested this, and in my opinion, I think this was probably the hardest problem on this year's AMC 10B. It could have been like a late AMY problem like problem 10 and still properly placed. So yeah. So the problem says, let ABCD be a rhombus with angle ADC is 46 degrees. Let E be the midpoint of CD, and let F be the point on BE such that AF is perpendicular to BE. What is the degree measure of angle BFC? So I've drawn out the diagram. We want to find angle BFC, so I go over here. ADC is 46, and AF is perpendicular to BE, and E is the midpoint of CD. Okay, so just looking at the diagram, there isn't really like an obvious way to start. The first thing I noticed was this weird quadrilateral here, ABED. So it kind of looks like a triangle that had its top chopped off. So if we were to extend BE past E such that it completed this triangle, we would have two similar triangles. So let's try that. We would have something like over here, I guess. Something like that. And I'll just call this point G. So we have two similar triangles because DE is parallel to AB, and they're similar in a ratio of 1 to 2 because DE is 1/2 DC and DC is equal to AB because it's a rhombus. So if these two triangles are similar in a ratio of 1 to 2, that means that these two line segments must be equal. And then also I'll just write this one in as well. Okay, so that doesn't really get us anywhere. So when you're stuck, just try something instead of just looking at the problem. So we can draw in line GC and see what that does for us. Might do something, it might not. And notice that we have this line CD, and it's cutting this in half. So it's a median of a line segment AG, and that might remind us of something. If you don't know, in a right triangle, if you draw the median from the right angle to the hypotenuse, it's actually going to be equal to 1/2 the hypotenuse. And we have a similar thing here, where we have, let's draw this in here. We have a line segment going from this angle here, ACG, to the opposite side, and each part is equal because CD is equal to AD, which is equal to GD. So we want to prove that this is a right angle, and that might be helpful for us. So how can we do that? Well, we know that GD is equal to CD, because GD is equal to AD, which is equal to CD. So let's just say this angle is X. Then this is also X because it's isosceles. This will be 180 minus X, or sorry, 180 minus 2X. This is 46, but we can just ignore that for now. Just say it'll be 2X, right? Because a line is 180 degrees. So if we have 2X here, and we have another isosceles triangle with ACD, So if this is 2x, this is 90 minus x, and this is 90 minus x. And that's how we prove that this is a right angle. We have 90 minus x plus x, which is 90. So ACG is going to be a right angle. And I'll just erase the other marks just to make it neater. Okay. So what does that do for us? Well, you might just like stare at the diagram for a while after this point, and eventually notice that we have a right angle here, and we have a right angle here. And you might recognize this as the angles in a cyclic quadrilateral. So if we have a quadrilateral inscribed in a circle, and you draw the diagonals in, this angle is going to be equal to this angle, because they share the same arc. And the opposite is also true if we have these two if we have two equal angles like this, that also proves that the quadrilateral is going to be cyclic. So what does that tell us? Well, it means that this entire quadrilateral here, AFCG, I'll write that down here, AFCG, is cyclic. And not just cyclic, we also know that this AG is going to be a diameter of the circle, because these are both right angles, which means it must be like half the circle must be on this other side, which I can't really draw in because it's too big, but half the circle is 180 degrees, so half of that would be 90 degrees, which is going to be these two angles. So AG is a diameter, which means D must be the center of the circle because it's in the center of the center of AG. And what does that get us? Well, now we have all the information we need to find angle BFC. So let's just start by doing this. Well, let's just draw part of the circle in to see what angles are subtended by what. We know that angle GFC, well, points G and C are on the circle because GD is equal to CD, and GD is a radius because it's half the diameter. So C must be in the circle. Actually, so does F, and we can prove that really quickly. If we just draw DF here, again, it's a median in a right triangle AFG, so this is also equal. So we know that points A, F, and C are on the circle. I guess we didn't actually have to prove that because we proved that earlier when we showed that AFCG is cyclic, but it's fine. Okay, so G and C are on the circle, and so is F. And so if we just imagine there's an arc here, GFC is going to be equal to GAC because A is also a point on the circle, and this is going to be equal to half of the central angle, which is GDC. Because D is the center of the circle. And so what does this mean? Well, we know that GFC is going to be equal to it's going to be equal to 1/2 GDC. And we know that GDC is going to be 180 minus 46. And that's going to be, what, like 134? So GFC is 67. Sorry, it's, yeah. So GFC is 67. And BFC plus GFC is 180 because it's a line. So then we have 67 plus angle BFC, which is what we're looking for, is 180. So BFC is 113 degrees. And that's going to be our answer, which is answer choice D. So yeah, this was probably the hardest problem on this year's test, Amc 10B. I read one of the solutions, and there was actually a really smart one, which basically said that these answer choices, I mean, there's no reason for them to be really close, except for the fact that, like, it prevents you from measuring the angle with, like, a protractor or something. And they must be related to 46 in a way. And then people noticed that 113 is just 46 divided by 2 plus 90. Just 23 plus 90, which is 113. Which is, I guess, a pretty smart way of recognizing how they're related. But this is, like, probably the fastest solution without fake solving it like that. So I hope you enjoyed. Be sure to like, comment, and subscribe. Sorry. And I'll see you in the next video.